Hello, in this lecture we'll answer on two questions. In the first question, we find out the length of this tangent MF that equals to x. In the second question, we find out the length of this tangent AP that equals to x. So we start with the first question. In the drawing, we have three identical circles, and we also have the big tangent ABC that is tangent to this circle at point A, it is tangent to the middle circle at this point B, and it is tangent to this circle at point C. In addition, we have also the convex point M. From this convex point M, we have tangent MD that is tangent to this circle at point D. The length of this tangent MD is 5 units. In addition, we also have tangent ME that is tangent to this circle at point E. The length of this tangent ME is 7 units. And finally, we also have tangent MF that is tangent to this circle at point F. The length of tangent MF is x. And our mission is to find out the length of tangent MF that equals to x. We have to find out the value of x. So first of all, and we also know that line segment AB equals to line segment BC equals to 3 units in its length. So first of all, we define the center of this circle. This point is point P. And we define the center of this middle circle. This point is point Q. And we define the center of this circle. This point is point S. In the next step, we join points P and T together by a straight line. PD, point P is the center of this circle, point D is the point of the circle itself. Therefore, PD is the radius of this circle. We define the radius of this circle as R. So PD equals to R. And because of the fact that those three circles are identical, the radii of those two circles must be also equal to R. And because of the fact that the radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle, and whenever your radius is drawn to the point of tendency, then tangent PD will be perpendicular to the radius MD. If PD is perpendicular to MD, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and P together by a straight line. By joining points M and P, we create the right triangle, triangle MPD. So in the next step, we will implement the Pythagoras theorem on this right triangle, triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle MPD is MP. Therefore, the square of the hypotenuse is MP squared. And MP squared must be equal to PD squared plus MD squared. Repeat again, according to the Pythagoras theorem, in the right triangle MPD, MP squared equals to PD squared plus MD squared. MP is the missing side, so we leave it as it is. This MP squared equals to PD squared. PD is R, therefore PD squared is R squared plus MD squared. MD is 5, therefore MD squared is 5 squared, that is 25. So in total, according to equation 1, we actually found out that MP squared equals to R squared plus 25. We repeat on the same process on this middle circle. That is to say, we'll join points Q and D together by a straight line. So QE is of course the radius of this circle that is equals to R. And because of the fact that the radius QE is drawn to point E, that is the point of tendency of tangent ME with this middle circle, And whenever you have a radius that is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If M is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points M and Q together by a straight line. By joining points M and Q, we create the right triangle MEQ. Inside this one, in the next step, we implement the Pythagoras theorem of this right triangle MEQ. According to the Pythagoras theorem, in this right triangle MEQ, MQ squared, that is the square of the hypotenuse, is equal to QE squared plus ME squared. Okay, again, according to the Pythagoras theorem, in the middle right triangle MQE, MQ squared, that is the square of the hypotenuse, is equal to QE squared plus ME squared. MQ is the missing side of electricity, so it is MQ squared equals to QE squared. QE is R, therefore Q squared is R squared plus ME squared. ME is 7, therefore ME squared is 7 squared, it is 49. So in total, according to equation 2, we actually found out that MQ squared equals to R squared plus 49. We repeat on the same process on this circle. That is to say, we join points S and F together by a straight line. SF, therefore the radius of this circle is equals to 1, and because of the fact that the radius SF is drawn to point F, that is the point of tendency of tangent MF in this circle, whenever your radius is drawn to the point of tendency, then tangent MF will be perpendicular to the radius FS. If MF is perpendicular to FS, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points S and M together by a straight line. By joining points M and S, we create the right triangle MFS. So in the next step, we will implement the Pythagoras theorem of the right triangle MFS. According to the Pythagoras theorem, in this right triangle MFS, MS squared, that is the square of the hypotenuse, is equal to SF squared plus MF squared. Okay, again, in this right triangle MSF, according to the Pythagoras theorem, MS squared, that is the square of the hypotenuse, is equal to SF squared plus MF squared. MS is the missing side of electricity, so it is MS squared equals to SF squared. SF is R, therefore SF squared is R squared plus MF squared. MF is X, therefore MF squared is X squared. So in total, according to equation 3, we actually found out that MS squared equals to R squared plus X squared. In the next step, we will join points P and A together by a straight line. Point P is the center of this circle, point A is the point of the circle itself, therefore PA is the radius of this circle that is equal to R. And because of the fact the radius PA that is equals to R. The radius PA is known to point 8, that is the point of tendency of tangent ABC with this circle. And whenever you have a radius that is known to the point of tendency, then tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. In the next step, we will join points Q and B together by a straight line. QB is of course the radius of this circle that is equals to R. Again, because of the fact that the radius QB is known to point B, that is the point of tendency of tangent ABC with this circle, and whenever you have a radius that is known to the point of tendency, then tangent ABC will be perpendicular to the radius BQ. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. And finally, we will join points S and C together by a straight line. CS is of course the radius of this circle that is equal to R, and again according to the same rule, rule 1, because of the fact that the radius SC is equal to R, the radius SC is known to point C, that is the point of tendency of tangent ABC with this circle, and whenever you have a radius that is known to the point of tendency, then tangent ABC will be perpendicular to the radius CS. If ABC is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. Those 3 points P, Q, and S, they are at the same distance from the straight line ABC. Again, the 3 points P, Q, and S, they are at the same distance from the straight line ABC. The distance between those 3 points P, Q, and S from the straight line ABC is R. And therefore, those 3 points P, Q, and S must be located on one straight line. That is to say, PQS is one straight line. So PQS is a straight line, and because of the same reason that the 3 points P, Q, and S are at the same distance from the straight line ABC, therefore the straight line PQS must be parallel to the straight line ABC. Okay, the straight line PQS must be parallel to the straight line ABC because of the fact that the 3 points P, Q, and S are located in the same distance from the straight line ABC. So here we can implement rule 17. So repeat quickly rule 17. According to rule 17, the sum of one-sided interior angles that are located between parallel lines is equal to 180 degrees. In the drawing, we have line A that is parallel to line B, and we also have the red line C. This is the red line C that intersects with those two lines A and B at those 2 points. We also have those two angles alpha and beta. Those two angles alpha and beta are defined as one-sided interior angles. They are one-sided angles because of the fact that those two angles alpha and beta, they are located at the left side of the straight line C. They are both located at the left side of the straight line C, and they are defined as interior angles because of the fact that they are located between line A and line B. They are located between the parallel lines A and B. So in total, those two angles, they are defined as one-sided interior angles. And according to this rule 17, the sum of two one-sided interrogals is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. The same rule is true for those two one-sided interrogals. The sum of those two one-sided interrogals must be equal to 180 degrees. That is to say, angle 1 plus angle 2 equals to 180 degrees. So we can implement rule 17 in our drawing. Why? Because in our drawing, those two angles are also defined as one-sided interangles, and they are located between the parallel lines PQS and ABC. And therefore, according to rule 17, the sum of those two one-sided interangles is equal to 180 degrees. But this is angle, a right angle. It is equal to 90 degrees. So 90 degrees plus the size of this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. According to rule 17, of course. Likewise, those two angles, they are also defined as one-sided interangles, and the sum of those two angles must be equal to 180 degrees according to rule 17. So 90 degrees plus the size of this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interangles. The sum of those two angles must be equal to 180 degrees according to rule 17. So 90 degrees plus this missing angle, in total must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. And finally, those two angles are also defined as one-sided interangles. And the sum of those two one-sided interangles must be equal to 180 degrees. So this is the right angle. 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So inside this quadrangle PQBA, we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So related to this quadrangle PQBA is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PQBA, side AB must be equal to the opposite side PQ, but AB is free, therefore PQ must be also equal to 3 units in its length. Likewise, in this quadrangle QBCS, we have 4 right angles. According to rule 5, any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So, related to this quadrangle QBSC, it's a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle QSCB, side BC must be equal to the opposite side QS. But BC is free, therefore the opposite side QS must be also equal to 3 units in its length. In the next step, I will copy the big triangle MPS in a new page and we will analyze this big triangle MPS. Okay, this is the big triangle MPS that I call it from the original drawing. This is line segment MQ that is defined as a median of this triangle MPS. A median is a line segment that connects the vertex of the triangle to the midpoint of the opposite side. So the median MQ starts from point M, that is the vertex of this triangle MPS, and ends at point Q, that is the midpoint of the opposite side PS. Why point Q is the midpoint of PS? Because of the fact that PS in total is 3 plus 3, that is 6, and at point Q, PS has been bisected into two halves. Each half equals to 3 units. PQ equals to 3 and QS equals to 3 units. Left. So the median MQ bisects the opposite side PS. Okay, again the median starts from the vertex and it connects the vertex to the opposite side PS, and it bisects the opposite side PS. That is to say, divides it into two halves. The first half is PQ and the second half is QS. But the question is, what is the length of the median MQ? Actually, we have a special formula that will help us to calculate the length of the median MQ. Actually, in the drawing we have triangle ABC. This is side AB equals to B units in its length. This is side AC equals to C units in its length. This is side BC, that equals to A units in its length. AD is the median of this triangle ABC, because it starts from the vertex A and ends at point D, that is the midpoint of BC. At point D, the opposite side BC has been bisected into two halves. The first half is BD, the second half is DC. So the median AD bisects the opposite side BC into two halves. But what is the length of the median AD? The length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. Again, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. We can use the new formula in order to find out the length of this median MQ of this triangle MPS. According to the new formula, the length of the median MQ will be equal to the length of the median MQ is equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. Repeat again. The length of the median MQ is equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2, according to the new formula. Here we multiply this equation 1 by 2, and we get that according to equation 1, two times MQ equals to the square root of 2MP squared plus 2 times MS squared minus PS squared divided by 2. Actually multiply the equation by 2, so it is not divided by 2, but actually after we multiply this equation 1 by 2, we found out that 2 times mq equals to the square root of 2mp square plus 2ms square minus ps square. So here we will square both sides of this equation 1. Two mq squared is equal to 2 squared, that is 4, times mq squared. So in total 2mq squared is 4mq squared. We will square also this side of this equation 1, and because of the fact that the square of, and the root are two opposite operations, the square will cancel the root, and we left only with what is inside this root, that is actually 2 times mp square plus 2 times ms square minus ps square. So according to equation 1, if we found out that 4 times mq square, according to equation 2, mq square equals to r square plus 49. Therefore, we substitute mq square here by r square plus 49, and it is equal to 2 times mp square. According to equation 1, mp square equals to r square plus 25. Therefore, we substitute mp square here by r square plus 25. And then also 2 times ms square. According to equation 3, ms square equals to r square, ms square equals to r square plus x square. Therefore, we substitute ms square here by r square plus x square, and then also here minus ps square. ps in total equals to 3 plus 3, that is 6, therefore ps square is 6 squared, that is 36. So minus ps square is minus 36. Yes, minus ps square is minus 36. Here we'll open the brackets on this on both sides of this equation 1, and we get that 4 times r square plus 4 times 14 is 196, so it is plus 196 is equal to 2 times r square plus 2 times 25 is 50, so it is plus 50, and then also here plus 2r square plus 2x square minus 36. So here we subtract 4r square from this equation 1. So here 4r square will get cancelled, and this side of the equation we left only with 196. On the other side of the equation we have 2r square plus 2r square, that is 4r square, so those two expressions will also get cancelled. And after we cancel 4r square, this side of the equation we left only with 50 minus 36, that is 14, plus 2x squared. So in total, according to equation 1, I shall find out that 196 equals to 14 plus 2x squared. Here we subtract 14 from this equation 1, and we get that 196 minus 14 is 182. So 182 equals to 2x squared. Here we divide this equation 1 by 2, and you get that according to equation 1, 182 over 2 is 91, so 91 equals to x squared. So here we take a root out of this equation 1, and you get that x equals to the square root of 91. The square root of 91 is 9.54 units. And that is the answer to the question. Okay, again, I shall find out that the length of this tangent MF is equal to either the square root of 91 in terms of numbers. The MF of tangent MF is equal to X is equal to 9.54 units. So we finish with the first question. In the next step, I present you the second question and solve the second question of this lecture. Our mission in this second question is to find out the length of this tangent AP is equal to X. We have to find out the value of X. So in the drawing we have quarter circle AOB. This is the quarter circle AOB. And inside this quarter circle we have this small circle. The small circle is tangent to tangent orbit point Q, and it is also touches the big quarter circle at this point. So when you find the touching point, this point is point K. When you find the center of this small circle, this point is point C. And we will join point C and Q together by a straight line. CQ is of course the radius of this circle, the radius of this small circle. So we define the radius of this small circle as A, so CQ equals to A, according to our definition. And because of the fact that the radius CQ that is equal to A, the radius CQ is drawn to point Q, that is the point of tendency of tangent OB with this small circle. And whenever your radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we will join point C and P together by a straight line. PC is of course the radius of this small circle, that is equal to A, according to our definition. And because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, and whenever your radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points A and C together by a straight line. By joining points A and C, we create the right triangle, triangle APC. So in the next step, I'll copy the right triangle APC. And in the page, we will implement the Pythagoras theorem on this right triangle, triangle APC. Here by PT is the version for Pythagoras theorem. So this is the right triangle APC that is coming from the original drawing. This right triangle APC, AC squared, that is the square of the hypotenuse, equals to AP squared plus PC squared. So I write it down. This will be equation 1. AC squared, that is the square of the hypotenuse, is equal to AP square plus BC square. AP is the missing side, so we leave it as it is. So it is AC square equals to AP square. AP is x, therefore AP square is x square. Plus PC square. PC is A, therefore PC square is A square. So according to equation 1, we should find out that AC square equals to x square. AC square equals to x square plus A square. As I already mentioned before, this is point K, that is the touching point between this small circle and this big quarter circle. That is to say, they touch each other internally at this point K. And whenever you have an internal notch between two circles, you can implement rule 9. So, I quickly on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects the circles together passes through their touching point. So in the moment we have two circles, the center of this big circle is here at point O, the center of this small circle is here at point M, and the straight line that connects the circles together is of course the straight line OM. And according to this rule 9, the straight line OM must pass through their touching point, that is point P. Again, according to rule 9, the straight line OM must pass through point P, that is their touching point. Or OMP is one straight line. Again, OMP is one straight line according to this rule 9. So we can actually implement rule 9 in our drawing. Well, because in our drawing, we have an internal notch between this small circle and this big quarter circle. So, the center of this big quarter circle is here at point O. The center of this small circle is here at point C. The straight line that connects the circles together is the straight line OC. And according to rule 9, the straight line OC must pass through their touching point, that is point K. Again, the straight line OC must pass through point K, that is their touching point. Or OCK is one straight line. Again, OCK is one straight line according to rule 9. So we join points O and C together by straight line, and according to rule 9, the straight line OC must pass through point K, that is their touching point. So it is very easy to see that the straight line OC indeed passes for point K, that is their touching point. Exactly according to rule 9. So in the next step, I'll copy. But what is the definition of line segment CK? Line segment CK starts from point C, that is the center of this small circle, and then at point K, that is a point on the small circle itself. So this is exactly the definition of a radius. Therefore, CK is the radius of this small circle, that is equal to A. CK equals to A. What is the definition of line segment OK? Line segment OK starts from point O, that is the center of this quarter circle, and then at point K, that is a point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, OK is the radius of this quarter circle. So we define the radius of this quarter circle as B. So OK equals to B, it is the radius of the quarter circle. OB is also the radius of this quarter circle, and therefore it is equal to B according to our definition. OA is also the radius of this quarter circle, that is equal to B according to our definition. So if I know that CK equals to A and OK equals to B, What is the length of this line segment OC? From the drawing it is very easy to see that OC in total equals to OK minus CK. Again, OK minus CK equals to OC. So I write it down. OC equals to OK minus CK. So OC in total equals to OK equals to B, is the radius of the quarter circle, minus CK equals to 8, is the radius of the small circle. So in total, we actually found out that OC equals to B minus A units in its length. So C equals to B minus A units in its length. So in the next step, I'll copy the right triangle OCQ in a new page, and we will implement the Pythagoras theorem on this right triangle OCQ. Here by PT is a version for Pythagoras theorem. We just right now found out that the hypotenuse OC equals to B minus A units in its length. Side Q is the radius of this small circle, that is A, and OQ equals to 5 units in its length according to what is given us the question. So actually, this is the right triangle OCQ that I copied from the original drawing. In this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus QO squared. So I write it down. This will be equation 2. OC squared, that is the square of the hypotenuse, is equal to CQ squared plus OQ squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equal to CQ squared. CQ is A, therefore CQ squared is A squared plus OQ squared. OQ is 5, therefore OQ squared is 5 squared, that is 25. So total according to equation 2, we found out that B minus A squared equals to A squared plus 25. B minus A squared is B squared plus A squared minus 2 times A times B, and it is equal to A squared plus 25. So here we have A squared on both sides of this equation 2, so A squared will get cancelled. After I cancelled A squared, in this side of equation 2 we left only with B squared minus 2 times AB. On the other side of this equation 2, we left only with 25. So in total, according to equation 2, we found out that B squared minus 2AB equals to 25. In the next step, we will do a construction. That is to say, from this point C, we will draw perpendicular on AO. Again, from point C, we will draw perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO. This point is point N. By doing this construction, we created quadrilateral NCQO. Inside this quadrilateral NCQO, we have 1, 2, 3 rectangles. The sum of three right angles is 270 degrees, so 270 degrees plus the size of this missing angle, in total they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral NCQO we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this right angle plus a square. So in order to this quadrilateral NCQO is right angle because it has 4 right angles. But you also know that the opposite sides of an rectangle are equal to each other. So an rectangle NCQO, side OQ must be equal to the opposite side NC. But OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the same rule, in the same rectangle NCQO, side NO must be equal to the opposite side CQ. But CQ is 8, therefore NO must be also equal to 8 units in its length. What is the length of the missing line segment AN? From the drawing it is very easy to see that AN equals to AO minus NO. Again, AN equals to AO minus NO. So write it down. AN in total equals to AO minus NO. So AN equals to AO. AO is the radius of the quarter circle that is B minus NO. NO equals to A. So in total AN equals to B minus A units in its length. AN equals to B minus A. So in the next step, I'll copy the right triangle ANC in the new page, and we will implement the Pythagoras theorem on this right triangle ANC. Here by PT is the version for Pythagoras theorem. So actually, this is the right triangle ANC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle ANC, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. So I write it down. This will be equation 3. AC squared, that is the square of the hypotenuse, is equal to AN squared plus NC squared. According to equation 1, AC squared equals to X squared plus A squared. Therefore, we substitute AC squared here in this equation 3 by X squared plus A squared. So AC squared equals to X squared plus A squared. And it is equal to AN squared. AN is B minus A, therefore AN squared is B minus A squared plus NC squared. NC is 5, therefore NC squared is 5 squared, that is 25. So in total, according to equation 3, we should find out that X squared plus A squared equals to B minus A squared plus 25. So X squared plus A squared equals to b minus a squared. B minus a squared is b squared plus a squared minus 2 times a times b plus 25. So here we have a squared on both sides of this equation 3, so a squared will get cancelled. After we cancel a squared, on this side of equation 3 we're left only with x squared. On the other side of equation 3 we're left with b squared minus 2 times ab plus 25. Again, according to equation 3, we found out that x squared equals to b squared minus 2ab plus 25. But according to this equation 2, b squared minus 2ab equals to 25. Therefore, we substitute b squared minus 2ab in this equation 3 by 25, and we get that x squared equals to, again, b squared minus 2ab 25 according to equation 2 plus 25. So in total, according to equation 3, we found out that x squared equals to 25 plus 25, that is 50. X squared equals to 50. Here we take out of this equation and finally get that x equals to the square root of 50. But 50 is 25 times 2. And the square root of 25 is 5. So in total this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. And that is the answer to the question. Repeat again, actually found out that the length of this tangent AP is equal to x. It is equal to either 5 times square root of 2 units. In terms of numbers, the length of this tangent AP is equal to x is equal to 7.071 units in its length. So finish with the second question. In the next step, I'll summarize the lecture. Let's start with the first question, of course. In the first question, our mission is to find out the length of this tangent MF that is equal to x. We have to find out the value of x. So in the domain we have 3 identical circles. We also have this big tangent ABC, that is tangent AB is tangent to this circle at point A, it is tangent to this middle circle at point B, and it is tangent to this circle at point C. In addition, we have this common point M. From this common point M, we have tangent MD, that is tangent to this circle at point D. The length of tangent MD is 5 units. We also have tangent ME, that is tangent to this circle at point E. The length of tangent ME is 7 units. And finally, we also have tangent MF, that is equal to x. Tangent MF is tangent to this circle at point F. MF equals to x, and we have to find out the length of tangent MF that equals to x. We have to find out the value of x. So first of all, we define the center of this circle, this point is point P. We define the center of this circle, this point is point Q. And we find the center of this circle, this point is point S. In the next step, we join points P and D together by straight line. PD is the radius of this circle. We define the radius of this circle as R. Because of the fact that those 3 circles are identical circles, the radius of those 2 circles must be also equal to R. So PD equals to R, and because of the fact that the radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle, whenever your radius is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If FD is perpendicular to DP, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and P together by straight line. By joining points A and P, we can get the right angle triangle MPD. So in the next step, we implemented the Pythagoras theorem on this right triangle MPD. According to the Pythagoras theorem in this right triangle MPD, actually according to the Pythagoras theorem in any right triangle, the square of the hypotenuse equals to the sum of the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MPD is MP, therefore the square of the hypotenuse is MP square, and it is equal to PD square plus MD square. Repeat again, according to the Pythagoras theorem in the right triangle MPD, MP square equals to PD square plus MD square. MP is the missing side, so it is as it is, so it is MP square equals to PD square. PD is R, therefore PD square is R square plus MD square. MD is 5, therefore MD square is 5 square. So in total, according to equation 1, we can find out that MP square equals to R square plus 25. Repeated on the same process on this middle circle. That is to say, we join points Q and E together by straight line QE is the radius of this circle that is R. Then we join points M and Q together by straight line. By joining points M and Q, here we have here triangle MQE, okay? But because of the fact that the radius QE is known to point E, that is the point of tendency of tangent ME with this circle, whenever your radius that is known to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. So by joining points M and Q together by straight line, we create the right triangle MQE. So I copy the right triangle, actually we implemented the Pythagoras theorem on this right triangle MQE. According to the Pythagoras theorem in this right triangle MQE, MQ square, that is the square of the hypotenuse, equals to QE square plus EM square. MQ square equals to QE square plus ME square. MQ is the missing side, so limit is it is, so it is MQ square equals to QE square. QE is R, therefore QE square is R square plus ME square. ME is 7, therefore ME square is 7 square, that is 49. So in total, according to equation 2, we actually found out that MQ square equals to R square plus 49. Repeated on the same process on this circle, that is to say, we join points S and F together by straight line. SF is the radius of this circle that is R. And because of the fact that the radius SF is known to point F, that is the point of tendency of tangent MF with this circle, and whenever your radius that is known to the point of tendency, then tangent MF will be perpendicular to the radius FS. If F is perpendicular to FS, it means that this angle equals to 90 degrees according to rule 1. The next step, we join points M and S together by straight line. By joining points M and S, we created the right triangle MSF. So we implemented the Pythagoras theorem on the right triangle MSF. According to the Pythagoras theorem, in the right triangle MSF, MS square, that is the square of the hypotenuse, equals to SF square plus FM square. And again, according to the Pythagoras theorem on the right triangle MSF, MS square equals to SF square plus MF square. MS, the hypotenuse, MS is the missing side, so it is it is, so it is MS square equals to Fs square. Fs is R, therefore Fs square is R square plus MF square. MF is X, so MF square is X square. So in total, according to equation 3, we should find out that MS square equals to R square plus X square. In the next step, we join points P and A together by straight line. PA is of course the radius of the circle that is R, and because of the fact that the radius PA is known to point A, that is the point of tendency of tangent ABC in this circle, whenever your radius that is known to the point of tendency, then tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we join points Q and B together by straight line. QB is the radius of this circle that is equal to R. Again, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points S and C together by straight line. SC is of course the radius of this circle that is equal to R. And according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So, the 3 points P, Q, and S are at the same distance from the third line ABC. Actually, the distance of point P from the third line ABC is R, the distance of point Q from the third line ABC is also R, and finally the distance of point S from the third line ABC is also R. So the 3 points P, Q, and S are located at the same distance from the third line ABC, and therefore they themselves must be located on one straight line. That is to say, PQS is one straight line, and for the same reason that the 3 points P, Q, and S are located at the same distance from the third line ABC, therefore the third line PQS must be parallel to the third line ABC. And because of the fact that PQS is parallel to ABC, we can implement here rule 17. So a quick review of rule 17. According to rule 17, the sum of one-sided interangles between two parallel lines is equal to 180 degrees. So in the drawing we have line A that is parallel to line B, line C intersects with those two lines A and B at those 2 points. We also have those two angles alpha and beta. Those two angles alpha and beta are defined as one-sided interangles. And according to this rule 17, the sum of two one-sided interangles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. So we can implement rule 17 in our drawing. Why? Because in our drawing we have those two angles that are defined as one-sided interangles. And because of the fact that they are located between the parallel lines P, Q, S, and ABC, the sum of those two angles must be equal to 180 degrees. So this is a right angle according to rule 1. So 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interangles. And according to rule 17, the sum of those two one-sided interangles is equal to 180 degrees. But this angle equals to 90 degrees. So 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interangles. And the sum of those two angles must be equal to 180 degrees. But this angle equals to 90 degrees. So 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. And finally, those two angles are also defined as one-sided interangles. And this angle equals to 90 degrees. So 90 degrees plus the size of this angle, in total the sum of those two angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. So in quadrangle PQBA we have 4 right angles, and therefore according to rule 5, this quadrangle there are PQBA is a right angle, but we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PQBA, side AB must be equal to the opposite side PQ, but AB is free, therefore PQ must be also equal to 3 units in its length. Likewise, in this quadrangle QBCS we have 4 right angles, and according to rule 5, this quadrangle QBCS is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle QSCB, side BC must be equal to the opposite side QS. But BC is free, therefore QS must be also equal to 3 units in its length. In the next step, I call it the big triangle MPS in the page, and we analyze this big triangle MPS. Actually, this is the big triangle MPS that I copied from the original drawing. This is line segment MQ. Line segment MQ is defined as a median of this triangle MPS. The definition of a median is a line segment that connects the vertex of a triangle to the midpoint of the opposite side. Here, the median MQ connects the vertex M to the midpoint of PS, that's point Q. Why point Q is the midpoint of side PS? Because of the fact that at point Q, side PS has been bisected into 2 halves. PS in total equals to 6. 6 over 2 is 3. So at point Q, side PS has been bisected into 2 halves. the first half is PQ that is free, and the second half is QS that is also free. So a median of a triangle bisects the opposite side to the vertex. Here the median MQ bisects the opposite side to M. The opposite side to M is PS, and at point Q, the side PS has been bisected into two halves. But the question is, what is the length of the median MQ? Actually, we have a special formula for the length of the median MQ. According to the special formula, here we have triangle ABC. Side AB equals to B units in its length, side AC equals to C units in its length, and side BC equals to A units in its length. AD is the median of this triangle ABC. It starts from the vertex and it connects the vertex A to the midpoint of BC. That is to say, it bisects side BC into two halves. The first half is BD and the second half is DC. But the question is, what is the length of AD? What is the length of the median AD? According to the new formula, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. So we can implement the new formula in order to find out the length of the median MQ. According to the new formula, the length of the median MQ is equal to the square root of 2mp squared plus 2ms squared minus ps squared over 2. Okay, and then again, MQ equals to the square root of 2mp squared plus 2ms squared minus ps squared divided by 2. Here we multiply this equation and equation 1 by 2. And finally found out that 2 times MQ equals to the square root of 2mp squared plus 2ms squared minus ps squared. Here we squared both sides of this equation 1. 2 times mq squared is 4mq squared, and because of the fact, so we squared also this side, because of the fact that the square and the root are two opposite operations, the square cancels the root, and we're left only with what is inside the root, that is 2mp squared plus 2ms squared minus ps squared. So in total, according to equation 1, we found out that 4mq squared equals to 2mp squared plus 2ms squared minus ps squared. So we have 4mq squared, but according to equation 2, mq squared equals to r squared plus 49. Therefore, we substitute mq squared here by r squared plus 49, and it is equal to 2mp squared. According to equation 1, mp squared equals to r squared plus 25. Therefore, we substitute mp squared here by r squared plus 25, and we have also 2ms squared. According to equation 3, ms squared equals to r squared plus x squared. Therefore, we substitute ms squared here by r squared plus x squared, and we have also minus ps squared. ps in total equals to 3 plus 3, that is 6. Therefore, ps squared is 6 squared, that is 36. So minus ps squared is minus 36. Again, minus ps squared is minus 36. So we open the brackets of both sides of this equation 1, and found out that 4r squared plus 4 times 49, that is 196, equals to 2r squared. 2 times 25 is 50, so it is plus 50, plus 2r squared plus 2x squared minus 36. Here we subtracted 4r squared from this equation 1, so here 4r squared will get cancelled. And here we have 2r squared plus 2r squared is also 4r squared, so those two expressions also will get cancelled. After we cancel 4r squared, in this side of the equation we have only 196. On the other side of the equation we have 50 minus 36, that is 14, plus 2x squared. So in total, according to equation 1, we can found out that 196 equals to 14 plus 2x squared. Here we subtracted 14 from this equation 1, and finally found out that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divided this equation 1 by 2, and finally found out that according to equation 1, 182 over 2 is 91, so 91 equals to x squared. Here we took out of this equation and finally found out that x equals to the square root of 91. The square root of 91 is 9.54. So in total, if we found out that the length of this tangent MF is equal to x, it is equal to either the square root of 91 units. In terms of numbers, the length of this standard MF is equal to X is equal to 9.54 units. Finish with the first question. In the next step, I present to you the second question and solve the second question of this lecture. In this second question, our mission is to find out the length of this standard. Our mission is to find out the length of this standard AP is equal to X. We have to find out the value of X. So at the drawing, we have quarter circle AOB, and inside this quarter circle AOB, we have this small circle. Tangent OB is tangent to this small circle at point Q. The small circle touches the big quarter circle at this point K. In addition, we know that this is line segment OQ, this is equal to 5 units in step. Again, our mission is to find out the length of this tangent AP, this is equal to X. So first of all, we define the center of this small circle. This point is point C, and we join point C and Q together by side line. CQ is of course the radius of the circle. We define the radius of this small circle as A. And because of the fact that the radius CQ is drawn to point Q, that is the point of tendency of tangent OB with this small circle. Whenever your radius is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 1. Likewise, we join point C and P together by side line. CP is of course the radius of this small circle, that is A, and because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, and whenever your radius is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees, according to rule 1. In the next step, we join points A and C together by side line. By joining points A and C, we create the right triangle ACP. So, we call it the right triangle ACP in the new page and implemented the Pythagoras theorem on this right triangle ACP. Okay. This is the right triangle APC, that is the correct from the original drawing. According to the Pythagoras theorem, in this right triangle ACP, AC squared, that is the square of the hypotenuse, equals to AP squared plus BC squared. AC is the missing side, so leave it as it is. So AC squared equals to AP squared. AP is X, therefore AP squared is X squared, plus PC squared. PC is X, therefore PC squared is X squared. So in total, according to the equation 1, we shall find out that AC squared equals to X squared plus A squared. We have here an internal notch between the small circle and the big quarter circle. That is to say, they touch each other internally at point K. And now you have an internal notch between two circles, you can implement rule 9. So I take place on rule 9. According to rule 9, if two circles touch each other internally, then the side line that connects the centers together passes for their touching point. In the drawing, we have two circles. The center of this big circle is at point O. The center of this small circle is at point M. And the side line that connects the centers together is the side line OM. This side line OM, according to this rule 9, must pass for the attaching point, that is point P. Again, the side line OM must pass for point P, that is the attaching point. Or O and P is one side line. Again, O and P is one side line according to this rule 9. So we can implement rule 9 in our drawing. Well, because in our drawing, we have an internal notch between this small circle and the big quarter circle at point K. The center of this big quarter circle is at point O. The center of this small circle is at point C. The side line that connects the centers together is the straight line OC. And this straight line OC must pass for the attaching point, that is point K. Again, the straight line OC must pass for point K, that is the attaching point, or OCK is one side line. Again, OCK is one side line according to rule 9. So we join points O and C together by side line. And you can see here that the straight line OC passes for point K, that is the attaching point, exactly according to rule 9. What is the definition of line segment CK? Line segment CK is the radius of this small circle, that is A. What is the definition of line segment OK? I said OK is the radius of this quarter circle, that is equal to B. So CK equals to A, OK equals to B. What is the length of this line segment OC? OC equals to OK minus CK. Again, OK minus CK equals to OC. Again, OC equals to OK minus CK. So OC equals to OK, that is B, minus CK, that is A. So in total, OC equals to B minus A units in its length. In the next step, I commit the right triangle OCQ in the new equation and implemented the Pythagoras theorem on this right triangle OCQ. This is the right triangle OCQ that I commit from the original domain. Just right now found out that OC, the opposite OC equals to B minus A. CQ is the radius of the small circle, that is A. OQ equals to 5 units in itself, according to what is in the question. According to the Pythagoras theorem, in this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus OQ squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equals to CQ squared. CQ is that, therefore CQ squared is A squared plus QO squared. QO is 5, therefore QO squared is 5 squared, that is 25. So in total, according to equation 2, I should find out that B minus A squared equals to A squared plus 25. B minus A squared is B squared plus A squared minus 2 times AB, and it is equal to A squared plus 25. Here we have A squared on both sides of the equation, so A squared will be cancelled. After cancelled A squared, in the side of the equation we left only with B squared minus 2AB, and the other side of the equation we left only with 25. So in total, according to equation 2, we should find out that B squared minus 2AB equals to 25. In the next step, we did a construction, that is to say, from this point C, we draw perpendicular on AO. Again, from point C, we draw perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the tension point of the perpendicular from point C and AO, this point is point N. By doing this construction, create quadrilateral NCQO. Inside this quadrilateral NCQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 facing angle in total must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this 4 facing angle must be equal to 90 degrees in its size. So inside the quadrilateral NCQO we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at its right angle in front of the square, so we relate to this quadrilateral NCQO as right angle because it has 4 right angles. But we also know that the opposite sides of right angle are equal to each other. So right angle NCQO, side OQ must be equal to the opposite side NC, but OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the symbol, in the symbol right angle NCQO, side CQ must be equal to the opposite side NO, but CQ is A, therefore NO must be also equal to A units in its length. What is the length of this line segment AN? AN equals to AO minus NO. Again, AN equals to NO minus NO. So AN in total equals to AO, that is B, is the radius of the quarter circle, that is B, minus NO, that is A. So in total, AN equals to B minus A units in itself. In the next step, I call it the right triangle NC in the new page and implemented the Pythagoras theorem on this right triangle NC. So actually, this is the right triangle ANC that I call it from the original drawing. AN equals to B minus A, NC equals to 5, AC is the missing side. So according to the Pythagoras theorem, in this right triangle ANC, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. According to equation 1, AC squared equals to x squared plus A squared. Therefore, we substitute AC squared here by x squared plus A squared, and it is equal to AN squared. AN is B minus A, therefore AN squared is B minus A squared, plus NC squared. NC is 5, therefore NC squared is 5 squared. It's 5 squared, that is 25. So in total, according to equation 3, we should find out that x squared plus A squared equals to B minus A squared plus 25. So x squared plus A squared equals to B minus A squared. B minus A squared equals to B squared plus A squared minus 2 times AB plus 25. Here we have A squared on both sides of the equation, so A squared will get cancelled, so we cancel A squared. In this side of the equation we left only with x squared. In the other side of the equation we left with B squared plus 2 times AB plus 25. But according to equation 2, B squared minus 2AB is equal to 25. Therefore, we substitute B squared minus 2AB here by 25. In total, we should find out that x squared equals to B squared minus 2AB is 25 plus 25. So x squared equals to 25 plus 25, that is 50. So x squared squared equals to 50. We took out of the equation and found that x equals to the square root of 50 units in its length. 50 is 25 times 2. And the square root of 25 is 5, so in total this expression equals to 5 times square root of 2 units in its length. 5 times square root of 2 is 7.071 units. So in total we have found out that the length of this line 7AP that is equal to x, it is equal to either 5 times square root of 2 units in its length, or the length of this AP that is equal to x is equal to 7.071 units in its length. Okay, thank you very much.